Hey AP Psych students, it is Megan here with Fiveable. It looks like we have a great crowd tonight, so I'm excited to review with you all. So, as I said, we are doing semester 1 review tonight. My name is Megan Ravello. I teach AP Psychology in Wisconsin at Middleton High School. I don't think any of my students are here tonight, but they'll get to see me live and in person tomorrow. So, my plan for the evening is to just do a really big overview, almost like an outline of each unit, kind of what I think the really heavy hitting points are. And then after each one, if there's something specific in more detail, I also have all of my unit guides open and ready, and I can flip to a certain topic and we can kind of go through some slides related to each topic. It looks like we have a couple questions already. All right, Peter is asking what topic is this up to, and I'm going through the cognition or the thinking unit. So I think it's units 1 through 6, and then next week we will be doing the rest of them. Good question. Darby, we are going to talk about Freud a little bit tonight, more so next week though. So there we go. All right, and then I do see another question in there, and I think we'll get to that a little bit later as we go, so keep that in mind. Unit 1, history and approaches. So like I said, I'm just going to kind of go into each topic and give an overview. So the history and approaches unit, that's unit 1, it's sort of our intro unit. There's not a ton of individual questions specifically that come from this unit. I feel like a lot of the multiple choice questions that are going to pop up on the AP test are going to relate to this plus another unit. So it's kind of our building blocks of the content. So the first thing that you need to make sure you understand is kind of this nature-nurture debate. That's one of the first issues that happen in psychology is, are we born, a blank slate, a tabula rasa, right? Or are we born with all of our knowledge is inborn, who we are, we're not going to change. And then so with that, make sure you kind of know some of the original philosophers. Typically speaking, on any given AP test, there might be one of those names on there asking you to identify their thoughts and beliefs. Some of the other historical names as well, knowing like Wundt and Titchener and those sorts of names that go along with these bigger ideas like structuralism versus functionalism. That's really maybe the only one I could see a specific question on. So make sure you know structuralism deals with the sort of how the mind is made up, all of the different pieces, right? Where functionalism looks at all of those parts put together and how it works. It's kind of like the pieces of the puzzle versus the whole puzzle put together. Biopsychosocial approach, make sure that you know and understand that basically anything that we talk about in AP Psych is not going to be just a biological thing or just a psychological thing. That to truly understand stuff, we have to look at all of the parts put together. The psychological perspectives. If you guys subscribe to the Fiveable Plus, I did a nice little hand thing that you can see a picture of here, but it basically gives you some mnemonic devices for all of the different psychological perspectives. For example, the thumb you can see is labeled as psychodynamic because it's buried deep in the past. Your thumb goes down, right? It's buried deep down in the past. Cognitive is like, I'm thinking about something. So make sure you know all those. But again, those are things that pop up over and over again in multiple units. So I don't think that's standalone. It's too hard to remember those. And then in my textbook, it also just talks about some basic careers in psychology in the intro unit. So I wouldn't stress too much about this unit. You're probably going to get 2 questions, maybe 4 questions on the AP test about it, and typically they will relate to other units as well. And so I did see that someone in the chat had asked, oh, they must have deleted it. Okay, we will come back to that then. All right, so that's kind of it for history and approaches. I do have 2 practice questions that can give you an idea of what those questions might look like on the AP test. You can see at the bottom of your screen, there's like a little poll thing that you can click on. So here's question 1. And so in that poll part, you can just click A, B, C, D, or E, what you think the answer is. It's totally anonymous, so you don't have to feel bad if you guess and you get it wrong. But this is just some practice that we'll do after each section. So a typical maybe Unit 1 question might be, which of the following would an industrial organizational psychologist be least likely to study? And so you have to know, what is an industrial organizational psychologist? What do they do? And so throw your answers in there in the poll. Again, it's totally anonymous, and you can change them after you guess. So keep going, and I'll wait. Since there's so many of you tonight, I'll wait till we at least get like 20 to 30 answers, and then we'll move on. Good. You guys are doing pretty well right now. Give you a second. All right, yeah, so for the answer for this one is D, corporate profitability. And so an industrial organizational psychologist is going to deal with like how employees interact with one another, how we can get the best work out of our employees, what ways can we, keep our employees happy and make them satisfied with their job. They're not going to deal so much with like the money business side so much of the company, but more about how the employees interact, how the employees feel, kind of like the psychology of working in a job environment, basically, is the gist of that. So that might be the type of question you get for Unit 1. Another might be this one. John B. Watson is best known as the founder of, so you can go back, it's the same poll question, you can just change your answer now from whatever it was, or maybe it's the same, I don't know. Give you a second, so just go back into that poll and you can change your vote to a different choice. And so this type of question is just taking one of the kind of original or one of the more famous psychologists and basically just identifying what they're famous for. Freud would be known for psychoanalytic. Watson is known for, and the answer here is A, behaviorism. Watson is known for the behaviorist approach. So those are the typically kind of common questions that I would expect to see from history and approaches. Maybe something that asks you about like introspection and things like that, but those are the sorts of questions to anticipate. So that's really it for that one. We're not going to spend a ton of time on it, but we're going to move on then to Unit 2, which is research methods. This is a bigger unit, so it is worth maybe probably about 8 questions on the AP test that you could expect. And so the big topics here that you need to make sure that you cover in your studying are descriptive methods. And so within descriptive methods, you need to be able to identify all of the parts of like a case study, all of the parts of a survey, parts of a naturalistic observation, and then also not just being able to identify what the parts are, but also like in what situation would I use case study versus survey versus naturalistic observation, that sorts of things. And then I also put under survey, making sure that you can identify population versus sample. Those two terms are kind of confused sometimes. And then also between random and representative and like what that means and how we get those. Logan in the chat, I do appreciate that comment. I agree. I can't set the crowdcast polling, but I do think that's a good point. We're all just going to conform. So try not to conform. Fight the conformity today. So that's kind of the descriptive methods, right? And you have to understand that descriptive methods are describing how things are, right? I'm not manipulating anything in that situation. And that's what sets like the descriptive methods apart from the experimental methods in our studies. And then for experimental methods, you need to make sure that you can Identify all the parts of an experiment, the experimental group versus the control group, the independent versus the dependent variable, how we would use random assignment and the benefits of those things. Those would be kind of how those questions I feel like would be aligned, like asking you to identify one of the parts of an experiment within a multiple choice question. And then talking about correlation and how, first and foremost, correlation does not equal causation. So don't get tripped up on a question where, you know, they're talking about correlational research and then they determine that this thing is happening, because we know that correlation does not equal causation. It can show a relationship, but not necessarily how that relationship exists. Trying to think. Descriptive statistics are important. Again, though, I don't know that this is a super stressful part of the AP test, because it's things like mean, median, and mode, which I feel like we learn kind of early on in our math classes. And so I don't know that there's a ton of confusion there. The big thing I know is that we have to be cautious about using the mean. Remember, make sure you like focus on this, or remember that the mean can really be skewed by outliers. That's a common thing that gets put on there. And so understanding that if a billionaire walks into Starbucks, all of a sudden, if we take the average of everyone's income, it's going to skew way higher because of that billionaire. So we have to be cautious when using the mean as a data, as a tool, as a descriptive statistic, because it can be misleading or skewed from outliers. And then dispersion measurements, just knowing what the range is, which is the highest score minus the lowest score. And then for variance and standard deviation, you don't really have to know how to calculate the scores out, but you do need to know that standard deviation is the square root of variance. So if variance is 100, standard deviation is 10. You have to be able to do that step, but you don't have to do all the steps leading up to that calculation. And then know that those show how much the scores disperse from the mean. As far as inferential statistics go, you do not need to know a ton about like what they all are besides statistical significance. So just like descriptive methods describe, descriptive statistics are describing our data or our population. And so inferential statistics allow us to infer or to make guesses or assumptions about our population with our data. And so how we determine whether or not our data is significant or valid is with this number called statistical significance. So that's the one kind of measurement you need to make sure you know. And then I see that there is a question in here related to research methods. That question is, what is the difference between a population and a sample? And so if I'm giving out a survey and I'm trying to find out how AP psychology students in the United States, how ready they feel for the AP test. I'm going to give you a survey that determines your readiness. My population then is all AP psychology students in the United States. But it's probably not feasible for me to send it to every single person. And so I'm going to take a random sample and send it to just 2,000 psychology students in the US. And so the population is the group that I'm trying to describe in total. And the sample then are the people that actually participate in the survey, which is typically not always the whole population. So the population is the whole group. The sample is the part that's being used to draw the statistics or the information from. So hopefully that helps. And then the last thing, I saw someone ask, how long is this live? I'll typically probably till 8. That's usually, I'm here about an hour. So we'll end by 8. And then lastly, ethical considerations. Just know the 4 main things are the main ethical considerations. We must get consent for someone to participate in the experiment. We must debrief them from the experiment. It must be confidential, and we shouldn't harm people. So those are the 4 ethical considerations. Looks like we have some more questions. Camilla is asking if we need to know null versus alternative hypotheses. I don't think so. I don't think I've ever seen that on an AP test. And so I would make sure you know just like hypotheses, operational definitions, kind of the basic stuff, but definitely not, you definitely don't need to know that. I don't personally think you need to know that much detail. That's my opinion. Amara's asking if there are any in-depth statistical questions on the test, and there is not. Nothing that you can't do without like by hand, because you can't use a calculator. So it should all just be basic math. Alexis, this is a live stream, so you can come back and watch it later if you have the subscription for Fiveable. But right now we're just live. Sorry. And then Alyssa is asking, do inferential statistics involve the whole population or a small group? Typically, it's still going to be like whichever group we've chosen to participate in our study. It's not going to be the whole population. However, the point of inferential statistics is that we take that data and then we can apply it later on to the whole population. If it's statistically significant, we feel safe in making assumptions then about our data. All very good questions, you guys. I think I got all of those. All right, so then just some samples of what a multiple choice question from this unit might look like. This one says, in order to yield information that is generalizable to the population from which it is drawn, a sample must be, and then your choices are A, B, C, D, or E. So just go into that same poll. Don't conform. Think about the answer yourself. Make your own choice. All right, so let's see how we're doing here. We're kind of split. The answer is representative of the population, because we want to make sure we've drawn, again, if I'm measuring AP psychology students' data, I want to make sure that I've taken people who are from all over the country, some boys, some girls, different socioeconomic status, different racial backgrounds, all of those different things. Because if I don't do that, then I can't really generalize about the whole population. If I just, ask my AP psychology students, that wouldn't be fair or representative of the population. Looks like we had a couple other questions about this unit thrown in here. Why would it not be C? Because a normal distribution just makes that normal curve, and not all data is going to form a normal curve. It depends what we're measuring. In some cases, we want to see a normal curve, like intelligence scores or things like that, but other statistical measures don't always fall into a normal curve. So it wouldn't always be true that we want the normal curve. And then Genesis is asking about the standard deviation and if it can be skewed if more data is added to the set. Typically speaking, standard deviation is less apt to being skewed because of the multi-step process that goes into calculating it. It kind of mitigates some of those skewing data. It could be skewed a little bit, but it won't be as severe as some of the other data systems. All right, let's look at one other question for this unit. Oops, sorry, this one's a little bit longer. An instructor conducted an experiment to determine the effects of two different methods of study on the amount students learned in introductory physics. The results showed that the average amount learned by the group using one method was greater than the average amount learned by the group using the other. However, the difference was not statistically significant. Which of the following is the most appropriate conclusion to be drawn? So take a second. Find your choice here. Oops, wrong thing. Getting some votes in. I'm seeing votes changing. And so the correct answer here is going to be E. There is a possibility that the difference occurred by chance. So when something's statistically significant, that means that we feel confident that whatever we're testing is having an effect or that it matters. And so if it's not statistically significant, then we're not very confident about that. That means that it could have just randomly happened. And so I'm not going to like say for sure that I can generalize those results. And so that's where statistical significance helps us in our like decision making about whether data is valid. Darby asked, I'm just looking at some more questions in here. What is a naturalistic observation? Just any sort of when you go out into the environment. So for example, if I sat in your lunchroom at your high school and took notes about high schoolers' behavior, I don't interact with you. I don't ask you any questions. I just observe in the natural environment and try to make inferences about teenage behavior in a lunchroom. Camilla's asking, how does random sampling affect the confounding variable? So well, we would say random assignment is going to, not probably random sampling, but random assignment is going to help us with the confounding variable. It should basically get rid of or at least lessen the effects of any sort of confounding variables. That's why we want it to be random so that people in the groups don't all have like similar traits or things like that, if that makes sense. And then Michelle's asking, will the questions on the AP test be similar in length, some long, some short? Yes, some of them are just going to be straight like Watson did this, and then some of them are going to set up a longer scenario and ask you to like apply some things. So there will be a varied length and structure. Good question. Megan, so when something happens because it was statistically significant, it is not by chance. We're saying that we're confident that whatever we were testing caused the differences. It's not by chance. Okay. Wow, you guys have a lot of really good questions. Genesis is asking about the standard deviation, the bell curve, the normal curve with the 68%. You should know those numbers. I can see if I can pull it up really quick here in my folder. So bear with me while I get into my research methods. And I think that's module 8. Nope, not module 8, module 7. So we have this. Oh, my computer is being slow. Maybe. We'll give it a second here. Okay. This is what Genesis is referring to, this normal curve. And I would say, oh, there we go. Hopefully, is that showing up for everyone? Can someone just tell me yes? Because my computer is being kind of funny. So yes, you do need to be familiar with this curve in particular and what this looks like. Basically, when we say that something falls into a normal curve, the mean goes right here at the middle of the curve. And then on either side of the curve, one standard deviation, which is that -1 + 1 that you see there. 68% of scores are going to fall within one standard deviation of the mean. And then if we move one step further out, then we're at about 90, what is it, 68 + 27. like 96% of scores fall within 2 standard deviations of the mean. I don't know that you need to know much beyond that, Genesis. I think you just need to know the 68 and the 96% numbers for that. So hopefully that answers your question. Okay. Yep, Alexis has said, do we need to know the percentages for the AP exam? Yes, you need to know the 68 and the 96 approximate percentages. I don't know that you need to go any further beyond that. That's typically what they would ask. And then you need to know like 34% is 1 standard deviation below, 13 below, and then above as well. So 68 and 96. Sorry if that was confusing. I'm just reading through these other questions. So as far as statistical significance, Zahara, I think what you're asking is that 0.05 or less than or equal to 5% is the number that we're looking for in statistical significance. So for us to consider our results to be statistically significant, we've just, sorry, my dog's having a fit. For us to consider those results to be significant, psychologists have just set an arbitrary number, and that number is 5%. And so if it's less than or equal to 5%, we're like, hey, it's statistically significant. If it goes even 0.1% above 5%, then we say it's not statistically significant anymore. And it's just an arbitrary number that we kind of set. All right, I'm gonna, okay, yep, we have a question about correlation. Strength of correlation, yep, it's as close as it is to, thank you. It's as close as it is to 1. So whether it's positive or negative, the stronger the correlation is shown by the closer the number is to 1. The closer it gets to 0, that means my scatter plot data is all over the place and I can't really see a correlation. The closer I get to 1, the closer my data gets to forming that one specific line that shows that there's a tight correlation of data. And yes, for example, negative 0.9 is a stronger correlation than 0.7 because the negative just shows the direction of the relationship. It just means it's inverse versus positive means it's positive correlation. Good question. And yes, these slides should be linked after the show. So if you want to go back through and look at the slides from the show tonight, they are all online. Okay, we're going to move on to the next unit because we are only in unit 2 and we're already at 7:30. But keep asking questions. This is good. I want to make sure we cover the things that you in particular want to cover. And now I've lost my regular slides. Here we go. We should be back to normal. All right, here we go. Next question, or next unit, sorry, bio. Bio's a big unit, but I think the positive with bio is that it's another one of those units where we kind of come back to it, right? We talk about different parts of the brain and functions as we go through other units. So while the first time you run through it, it's a little scary, then it gets a little bit better as we go. And so for bio, I want to start with just you need to know the neuron. You need to know the parts of the neuron, the dendrites, the terminal buttons, the axon, all of that stuff. You need to know it. And then you need to know how the neuron functions. So how it talks to itself, you know, from one end to the other, but then also how it communicates and talks to the other neurons in the brain and in the body. So that is one thing. And that's like a lot of things rolled into one, but that's a very common question about bio, is something to do with like parts of the neuron or how the neuron functions. Okay. And then neurotransmitters, make sure you know the basic ones that are listed: acetylcholine, serotonin, dopamine, GABA. I know I'm missing some right now. GABA, glutamate, I think that, and norepinephrine. And so for those same sorts of things, know whether they act as like agonists or antagonists, what they function, that sort of thing. And like to refresh your memory, an agonist is like a helper, right? It binds to and makes you get more of that specific neurotransmitter. It's like an addition, and an antagonist kind of works against or slows it down, that sort of thing. Looks like we have some more questions. Okay, then for the nervous system, just kind of comparing, not contrast, but know that the peripheral nervous system is all of the parts kind of coming out from your spinal cord. The central nervous system is like your brain and spinal cord. Autonomic versus somatic, and then sympathetic versus parasympathetic. Earlier in the year for the nervous system, I showed a little dance that was made up that goes with the different parts. So if you, again, subscribe, you can go back and look at some of those. Make sure you know the different tools of discovery, like MRI, fMRI, PET scan, CAT scan, all of those different things. Those are pretty straightforward. And then this is really broad, I know, but you need to know the big parts of the brain: hippocampus, hypothalamus, medulla, all the different like lobes, frontal lobe, that sort of thing. Make sure you just know the really basic functions. I would never go and just start like Wikipedia-ing, because that's going to give you way too much information. Just make sure you know the basic, like whatever your textbook says, like hippocampus deals with memory. That's what you need to know. You don't need to know all the extra stuff that goes along with it. And then in this unit, there's just some other odds and ends, like brain plasticity, what happens to a split brain patient, how twin studies and heritability and things like that work. And so looks like we have quite a few questions in here. So let me get to some of them. Let me see here. Okay. So NJ is asking about the neurotransmitters. So what I will do here is bring up my chart really quick of the neurotransmitters that you need to know, which is going to be right here. Oh my gosh, why are my slides so slow today? So for the neurotransmitters, for the agonist and antagonist piece, you need to know the agonists bind to the receptor sites and mimic their effects, whereas the antagonists block their effects. And I guess I don't have a specific neurotransmitter slide. Let me see. So, okay. Unfortunately, I don't think I have a, why do I not have a slide? I don't have a slide about all of the different parts of the neurons. So what I will do is for next week, I'm going to write that down, and I will make a slide that just outlines like maybe a chart of each part of the neuron, or each of the neurotransmitters, that gives you just the basic like name, function, and then like malfunction, because that's kind of a common question. And then that way you guys can just kind of screenshot it or take a picture and study from that chart. So that's what I'll do for next week. I apologize. I thought I had a chart already for that. And Darby, that also answers your question about the ones that you need to know. Do agonists and antagonists apply to all neurotransmitters? Typically, I see it used maybe more with like drugs and medications, but it can also apply to the neurotransmitters. So I would say maybe not always, but some of the time to that question. And then Erica is asking about like brain plasticity and what is it? And it's basically just this idea that our brain can change and function, and parts of our brain can grow. And there's even studies that show, like, depending on who injures their brain and when, that neurogenesis can happen and we can grow new neurons and the brain can repair itself. Basically, it's kind of like this idea that the brain is somewhat flexible in how it changes and grows. It's not always just like if you have damaged a certain part of your brain that that part is just gone forever. Okay. Yeah, we can go over tools of discovery. Okay, looks like we want to go through the, geez. Sorry, you guys, there's just a lot of questions. Tools of discovery. All right, we'll go over that in a little more detail. So tools of discovery, I think you just kind of need to know for each one the method that would be used in that case to study each system. So for example, oh my gosh, the internet is not good at my house tonight. EEG is the recording of brain waves that sweep across the brain. We measure it by electrodes, and it just measures activity. It doesn't tell me anything about the structure of the brain. It just tells me about the activity happening inside the brain. A CT scan is going to use X-rays to envision the brain structure, and it can reveal if there's damage. So if there's like a really weird dark spot where we wouldn't anticipate there to be one. And then the key there is that one measures anatomy. Positron emission tomography scan is a PET scan, and it shows brain activity based on how our brain like reads this chemical consumption. And so this shows activity. And so if I'm putting the radiation basically through your brain, and then I ask you to do a certain task, I can look at what parts of your brain light up, and it can kind of tell me which parts of your brain control different activities and functions. An MRI uses radio waves to show the brain's soft tissue. So again, this is an anatomy scan. It's just showing me what the brain looks like and if there's damage to certain parts of it. And then an fMRI, probably the best tool that we have because it shows both the anatomy and the function of parts of the brain. So yeah, that's a brief overview then of the various parts of the tools of discovery. Hopefully that was helpful. Let me see, types of conditioning. Okay, I think there's one other, okay, there's something about the potassium and the sodium and potassium channels in the neuron. So I have a diagram I can show you guys. Just close some of these. There is basically what happens is that the neuron communicates due to the depolarization. And so as the ions flood in and out, the neuron then is trying to repolarize itself. And so the sodium and potassium are what's polarizing and depolarizing the neuron and allow that functioning to happen. And so this is the picture from your textbook if you have the Myers book. But basically, the electrical charge produces depolarization. So the negative ions and the positive ions are switching places. And as they do that, as you can see, it like works its way down the neuron. The gates open up in the neighboring like channels, and then the charged sodium ions rush in, which pumps out the sodium ions back out, and then in and out, in and out. It's sort of like a wave of how that works. I don't know that you're going to need to know much beyond that specifically, but just that it's this idea of depolarization down the axon that causes the message to travel along the neuron. I think that's about as in-depth as the information is going to be that you're going to need for that question. So good question. First. So split brain, we have a question about split brain. So basically, split brain happens when I cut your corpus callosum. Remember, your corpus callosum is what connects the two hemispheres of your brain. If you don't have that, you can still function as pretty much a quote-unquote normal person. It's just that the don't communicate with each other. So the left hemisphere of your brain controls the right side of your body. And so if I see something in my right eye, it goes to the left hemisphere in my brain. And then it can be, like if I said, draw what you see, and you see it with your right eye. I see a cat. The message cat from my right eye goes into my left brain, and then my left brain sends that message to my right hand, and it says draw a cat. So it just crosses back and forth. And so in theory, I could have two pens in each hand, and I could draw two different things because my right eye sees one thing and my left eye sees the other. And so the trickiest part about split brain is just making sure to that the message crosses, that whatever's happening on the right side is going to the left brain and then back out the right side. I think that's the trickiest part to try and remember. Okay, and then there's a question just about association areas. Basically, like, you just need to know association areas are going to be kind of all of this like higher functioning extra stuff. I don't even spend a lot of time talking about it with my students. It's just, yeah, so kind of higher level functioning things like critical thinking and these things that we maybe don't have anywhere that's pinpointed to a specific part of the brain, like a memory or things like that. That's more of what the association areas are. And we still are learning a lot about them. And Aya, yes, that is a fun fact. You could do both things at the same time. Okay, let's do a couple of those questions and then let me come back and see if we have more in the question box here. Okay. So this might be a typical, just a really straightforward bio question that we see. The area of the brainstem that is important in controlling breathing is here's a function. Who is responsible, or what is responsible for that function? So I'll give you a second, vote in the polls. While you guys are answering that, Megan just asked a question about zero and correlation. I'm just going to go back to that. Yeah, zero means there's no correlation. The dots would just be completely scattered. There would be no like pattern. Okay. All right, and then the answer to this is D, medulla. The medulla is responsible, right? It's at the base, the brainstem back here. It has to do with just basic function like breathing and heart rate. If you didn't have it, you wouldn't be alive, basically. So pretty important. So that's a typical bio-type question. This is another typical bio-type question. Which of the following is the correct sequence of the neural chain of events set in motion by an environmental stimulus? So this is asking you to basically say, how does sensory input get taken all the way in and, yeah, processed in and back out, basically. So I'll give you a second since there's a lot of choices here that you have to read. Use some process of elimination skills. All right, the answer to this one is A, receptors. I think that's kind of your first hint, is that, yeah, we need a receptor. And so that should be narrowing down your choices to A or B. And then we go from there to the afferent neurons. And how I remember this is the afferent are also our sensory neurons, and A comes before E, efferent. So the A happens first alphabetically and in our neurons. So we have receptors, A for afferent neurons. Interneurons are in the middle, right? Our efferent neurons, and then our effectors. And so if that helps you remember it, that is kind of what I would choose to do. So, okay, that is another typical sort of bio type question. Types, functions of parts of the brain, or how things function together as a whole. We have a lot of questions here. I'm going to... Okay, we haven't talked about Broca and Wernicke's area yet, so I'll pull that question up. Miriam's asking about Broca versus Wernicke's area. Broca's area deals with like producing speech. So it like makes it capable for me right now to be pushing these sounds and words out of my mouth. I'm making the speech physically. Wernicke's area is going to deal with more of like understanding speech and making it make sense. Someone with damage to Wernicke's area might be able to talk, but what they say isn't going to make sense. It's not going to flow, and they're going to kind of think they're making sense and think they're communicating with you, but it might end up all jumbled and kind of like word salad, we might call it. So that's the difference between the two of those. And then Rohit's asking about afferent versus efferent neurons. Afferent are sensory neurons, and efferent neurons are the motor neurons. Sorry, I was drawing a blank. So afferent is what brings the message in. It's the sensation part. And then efferent is what sends the message back out to like move my arm, move my hand, things like that. So those are sort of, yeah, those two functions. Okay. Genesis asked if we need to be able to actually like label on a diagram. One time I've seen a diagram about the brain stem. You had to label the pons on it. So I'd say it's not super common, but it has appeared on the test. And that's with like a lot of this stuff. There's just stuff that you can't stress about, right? There's just no possible way that you're going to be able to cover every single base. And so it's basically about hitting the things that are more common and making sure you feel really confident about those. It gives you a better, advantage going into test day. Like I said, we'll cover neurotransmitters. I'll come back to that next time. I'll make a chart for next week. And then I'm going to jump ahead now to the consciousness unit because I see that we do have questions related to that. And so I want to make sure that we're getting ahead a little bit. We'll do sensation and perception really quick and then consciousness before we end tonight. So sensation and perception, this is another pretty big unit. Some of the big things here are just knowing the difference between sensation and perception, which is like a whole section in the book, how we like pay attention and like how thresholds impact that. So like what's my absolute threshold, what's a difference threshold, and then how does Weber's law play an effect in that. For vision, you need to know the different parts of the light spectrum. So like the Roy G. Biv, right? Long light waves to short light waves. What wavelength and amplitude mean. So like the pitch sound, it's like pitch or the intensity of what we're seeing. The different parts of the eye. And unfortunately, I saw someone in there ask if I had a mnemonic device. I don't for parts of the eye. Again, I don't know that that is something that you're going to have to know. It might ask you like in what order does light pass through the eye, and you'd need to know that. But again, it's so uncertain that I can't guarantee that would be on the test. And then the theories of color vision. Erica asked in the chat, what is Weber's law? And Weber's law just says that the difference that it takes for me to notice a change in a sound, in a smell, in a intensity of a light varies by a constant proportion. So if I have to turn the volume up 5% to notice a change, then I need to turn it up 5% more to notice another change, and then 5% again and again. It's a constant proportion. It's not 5 notches on the dial. It's 5% or whatever the percent is. I just made that number up. As for hearing, same sorts of things. You have to understand what wavelength and amplitude mean for hearing, which is like how loud a sound is and how high or low pitched it is. Parts of the ear, types of hearing loss, and theories of pitch. Zara, I don't know that you need to actually be able to label it. Again, there's been times where that's popped up on the AP test, not labeling the whole thing, but they might have like a drawing to one part of it. But again, that's pretty rare. And I would say if you know the basic order, you could probably use process of elimination to get to the right answer with those. And then the other senses really aren't covered a ton. I would focus mostly on vision and hearing. For touch, you just need to know that we have like pain receptors and things like that. And then for smell and taste, they're just not super common things that are asked about. They might pop up, but make sure you just know the basic gist of like how those senses function. And then know that there are other senses like kinesthesia and the vestibular sense as well. Okay, okay, I think I did that. All right, I don't see too many questions relating to this unit. And so I'm going to just quick power through the 2 questions and see if we can get through consciousness yet as well. So the perceived pitch of a tone is largely determined by its, so this gets into that like wavelength question, or what is it? Is it frequency? Is it amplitude? Is it loudness? How do we hear a pitch? What determines that? So go into the polls. Okay, and the answer is E for that one. Good. Frequency. So like how fast basically that wavelength is moving determines the pitch of what we hear. If it was for loudness, how loud or how quiet a sound is, that has to do with the amplitude of the wavelength. And then if this was a question about vision, amplitude deals with, or wavelength deals with the color that we hear, and then the amplitude is how intense that color is. Okay, looks like there's some more questions in here. Okay. All right, kinesthesia versus vestibular sense. Kinesthesia has to do with like basically like knowing how my body is and how it's moving. So like right now I know that I can touch my nose without really thinking about it. Like my body knows like where it is and what it's doing. It's kind of dealing with like movement. Vestibular sense deals with balance, and it has to do particularly with your semicircular canals. They're filled with fluid. And so like when I ride a roller coaster or a spinny ride, that fluid like shakes up a bunch, and then it makes me feel dizzy. And so vestibular is more with like balance, whereas kinesthesia is more about like movement, if that is helpful. Some of these we've touched on. Okay, so I think what I'm going to do in the last 4 minutes, there's a couple questions that have a lot of upvotes here, and I'm going to talk through them. And then what I can do next week is I will kind of keep this same format going, and we'll review a few more of the units. Maybe I will take out some of the smaller units and make sure that we come back to, and then I might take out the abnormal unit just because we've just kind of covered it. So these last few questions that are in here for tonight, this one says, how can I differentiate between the different parts of the drug? Also, how to remember the different parts sequence of the eyes and ears. So for the different categories of the drugs, I would say think about like I mean, in your health class or what you know about people who take drugs, but like basically there's kind of two main categories, right? Amphetamines make you like hyperactive and active, and then barbiturates kind of bring you down and make you sleepy. And so I would just kind of think about like, okay, alcohol is a depressant, so it depresses your nervous system. I don't know that there's any specific trick to it, and I don't know. That's a pretty short unit too. I think if I wouldn't stress about it a whole lot, you might get one or two questions about drugs on the test. But just basically thinking about, does this drug make someone super hyperactive, or does this drug kind of bring someone really down and mellow them out? Or I guess the third category is, does it make you hallucinate? Those are the three categories of drugs. And so just kind of knowing like a little bit about that, either if you've taken a health class or things like that, that's probably the best approach. And yeah, as for parts and sequence of the eyes and ears, I don't have any fancy way to remember it. I'll look around this week, and for next week, I'll see if there's some sort of mnemonic device out there that I can make up or find, and I'll add that as well as the stuff about the neurotransmitters for next week so that we have a nice, easy visual to look at. Because to me, that's the most beneficial, is just having like a one picture kind of summary of that sort of thing. This question's about the difference between longitudinal and cross-sectional method. So a longitudinal study takes a long time, long time. And so in a longitudinal study, I'm going to study the same person over and over again. I'm going to get your information at 5 years old, at 10 years old, at 15 years old, at 20 years old, et cetera, et cetera. And then I'm going to measure the growth and the changes that you experience. The cross-sectional method is done all at the same time. I pick a 5-year-old, I pick a 10-year-old, I pick a 15-year-old, and then I get their information and compare the results. So longitudinal is the same person being measured over and over again, whereas cross-sectional is people measured at the same time from different age groups. And there's pros and cons to this. The longitudinal study means that I'm studying the same person, so I can genuinely see changes that occur. However, the problem with longitudinal studies is that they take a long time. People may die. People may not be interested in participating in the study anymore, which can skew our data. Cross-sectional is good because it's like, hey, we can get this done right away and study, compare groups. But then we might be comparing people, like, think about a 90-year-old. A 90-year-old didn't grow up with the internet, had different nutritional habits, different educational habits. And so comparing a 90-year-old today to someone like me who grew up with the internet, we're going to have like differing results because people grew up in different ages, in different ways. So that can be problematic. The different types of conditioning, stimulus response. I have a chart for that for next time, and I will make sure that we look at that chart, that visual, so that you can have a visual for that information. We'll cover that next time. And then heuristics and cognitive bias will be covered next time. And then Natalie asked about hearing loss. There is conduction hearing loss, and now I'm blanking on the other, conduction and neural hearing loss, sensory neural hearing loss. And so one deals with the structure of the actual ear being damaged, and the other is damage to like the cells and the neurons, the sensory neural thing. Left and right brain, typically, that's another question someone's asking about left and right brain. Left brain deals with a lot of the L words like language and logic. And then right brain tends to deal with more like abstract concepts, more creativity, things like that, typically speaking. But again, brain plasticity and stuff like that says that those things sometimes change. Again, it's easier when you're younger, but it does happen. Okay, that's all I think I'm going to cover tonight. You guys had so many great questions, and I'm sorry that I couldn't get to them all. We do have a student Facebook page that I'm a member of, and so if you really feel like something didn't get answered or you thought of something after the fact, go on the student Facebook page, and I will be on there, and I'll interact with you on there. I'll try and log on at least once a day and get back to you guys. So that's sort of it then for tonight. Next week, I will come back to the neuron thing. I'll try and come up with some eye and ear mnemonics for you guys, and then we'll cover some of those bigger units yet that we haven't gotten to, so there'll still be plenty of room for Q&A. So again, either hit me up on the Facebook page, make sure you subscribe. You can go back and watch some of the previous sessions. That might help as well. There's some visuals and things on there. And otherwise, I will look forward to seeing you guys all next week when we're getting super close to the AP test and we're all going to rock it. So have